Congruence, I have a 90-degree angle, and then the hypotenuses are the same and an angle, so that would be hypotenuse angle. 3 sides. I have not hypotenuse, a side, an angle, and a side. And then I have a 90-degree angle, but I don't know that the hypotenuses are necessarily the same, but I do know that, yeah, the leg, wait, no, hold on, sorry. I do know this because these two angles are the same, that makes these two legs the same. So I have hypotenuse angle, or hypotenuse leg. Either one would actually work on this one. Okay, so this is the one I was talking about on Monday where I said the last line of the proof is always the same. We have to prove triangles are congruent, and then once we prove the triangles are congruent, we can prove that a part of the triangle is congruent. So certain angles or certain sides are congruent, because if you have congruent triangles, then all of the corresponding parts are congruent, and that's corresponding parts of congruent triangles are congruent, or CPCTC. And when on these proofs, this is always your last line of the proof. So we prove the triangles are congruent using one of our methods: side, 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 angle, side, angle, side, angle, 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 side, hypotenuse leg, or hypotenuse angle. Once we say the triangles are congruent, the next line is going to be, always? Yeah. So you get the triangles congruent, and then the next line will be like, these angles are congruent because of CPCTC, or these legs are congruent because of CPCTC. And you don't have to write out the whole long thing. You can just write CPCTC. So I have angle 1 is congruent to angle 3. And then I have angle 2 is congruent to angle 4. And I want to prove that XW is congruent to YZ. So first I have to prove that these two triangles are congruent to each other. So my first statements are, of course, the given. Okay. Now, I have two angles that are congruent. If I go backwards just for a second, that gives me angle, side, angle, or angle, angle, side. So if I look at my picture, if I did angle, 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 side, I would have to know something about either this side or this side, which I don't. So it has to be angle, side, angle. And I know that this is congruent for both triangles because it's the same line, right? So XZ is congruent to itself because it's reflexive. Which makes now you'll notice I was very careful with my order. I did X, W, Z, so angle 1, non-numbered, angle 4. So when I wrote the next one, I had to do Z, Y, X, so that my congruent angles are all in the same order. They're congruent, oops, because of angle, side, angle. And then the last line is whatever I was trying to prove. CPCTC. Darn it. Okay, so LO is the same as NO. That's this line is the same as this line. And LM is the same as NM. That was also given. How do I know MO is the same as MO? Well, it's the same as itself, right? Anytime you're talking about something being the same as itself, it's reflexive. And how do I know my triangles are the same? Okay, I've got 3 sides that are all marked, so that's side, side, side. And what's the last line going to always be on these? Guys. CPCTC. Okay, it's given. Q is the midpoint of PS and TR. That means that because it's a midpoint, it cuts things in half. So the halves will be the same length as each other. So that's the definition of midpoint. Anytime you're given something like bisecting or midpoint, your next line in your proof is usually going to be to define them. So I say, okay, well, if this whole line was bisected, then these 2 parts are the same size. Okay, angle PQT, so I have 2 sides, right? So to determine congruency of triangles, if I have 2 sides, I need to either come up with an angle that's the same for side, angle, side, or the other side that's the same for side, side, side. Those are the 2 side versions that I have with the 2 sides. I don't know anything about these 2 lengths, but I do know that these are vertical angles. So that's what I'm going to say. These angles are congruent because they're vertical. And if you don't want to write out the letters PQT and SQR or whatever, you can always just number them 1 and 2 or something and say angle 1 is congruent to angle 2. That's fine too, as long as you number the picture so I know what you're talking about. So then the triangles are congruent because I have side, angle, side. And the last line on these is always going to be CPCTC, because if the triangles are congruent, then these other angles are congruent because they're part of congruent triangles. We have the isosceles triangles. So if these 2 sides are the same, then these 2 angles are the same. So if this is x, this is also x. And what I have is 90 degrees and then x plus x, and triangles add up to 180. So 2x is going to be 180 minus 90. So 2x is going to be 90. So x will be 45. Okay. If I have 3 angles that are all the same, they're going to be 60 degrees each on the inside. But I want to know the outside angle, and these make a straight line, so it's going to be 180 minus 60, so it's 120 degrees. If I have 2 angles in one triangle that are the same as 2 angles in another triangle, then these angles would also be the same, which makes these congruent triangles, which means these sides will be the same. So x will be 32. Making sense so far? And then finally, again, I have isosceles triangles, which means that these 2 angles will be the same. Well, if these are congruent to those, then that means these angles are all the same, and this is also 92. So then that's x, so 2x. So that would be 90 minus 2, which is 88, is equal to 2x. So x would be 44 degrees. Okay, so a median goes from a vertex to a midpoint on the opposite side. So that's like a median right there. Of course, it's a straight line when it's a real median. Actually, I don't want to make it blue. Okay, so being that this is a midpoint, these are going to be the same length. And every triangle has 3 medians, so it would have a median from this vertex to this side and this vertex to that side. An altitude is going to go from a vertex to a 90-degree angle with the opposite side. So a median might go to a 90-degree angle. You can be both a median and an altitude at the same time, but not every median is going to be a 90-degree angle, and not every altitude is going to go to a midpoint. Bisectors are perpendicular to segments, and I didn't draw that in half, and cut them in half. So it's going to be a 90-degree angle, and then the segment is going to be split into equal parts. And equidistance just means that this distance is the same as this distance. So these 2 points would be equidistant to that line segment. All right, we have some theorems. If a point is equidistant from the sides of an angle, then it lies on the angle bisector. So if I have some angle, okay, and I have some point right here, and this distance are the same, then that point is on the angle bisector. And so that's the bisector cuts the angle in half. Vice versa, if I have some angle and it has a bisector, okay, so if you're a point and you're on an angle bisector, so these are an angle bisectors, that means that you're equally distant from the 2 sides of the angle. If you are on a segment, sorry, you're not on a segment. There is a segment, right? And you have endpoints, and you have some point out in space, and these 2 distances are the same to the endpoints. That means you're on the perpendicular bisector. And vice versa, if you are on the perpendicular bisector, that makes the distances to the 2 ends the same. So these go backwards, both of them. Okay. All right, if we have an altitude, altitudes are 90-degree angles. So if I have an altitude, that means this is equal to 90 degrees. So then I'll just solve it. So I'll add 15 to both sides. And I'll get 3x is equal to 105. Divide by 3, and you get x is equal to 35. All right, if I have a bisector, that means these 2 angles are the same, which means these 2 distances are the same. So I'm going to set those 2 lengths equal to each other. Subtract 2x from both sides. And I get x minus 5 equals 17. Add 5 to both sides. Yeah, I will. For B, we have perpendicular bisector. Bisecting means that these 2 lengths are the same. So I'm going to set those 2 things equal to each other and solve it by subtracting 1 from both sides, which gives me 2x equals 22, which means x is 11. Sorry, that's sort of squished. For C, we have that AB is an altitude, which makes these both equal. So I'm going to set them equal to each other. Subtract x from both sides. Did you guys notice pattern yet? Add 6. 2x equals 20. So x equals 10. Set them equal to each other, yeah. Subtract 3x. And I get 3x minus 15 equals 30. Add 15. And I get 3x equals 45. And if I divide both sides by 3, I get 15.